Hi everyone, what's up? How are you guys doing today? Hope you've been having a really good day. We've been looking at matrices, or we've talked about matrices in the past, so we just want to look at a different part of it in today's lesson. We are going to be looking at a number of examples. So we'll be solving about five exercises, different kind of exercises, different shades of exercises, and then we are going to have an assignment for you to like work with. So the kind of matrices that I want to do today is the type where you are going to be looking for a particular unknown. So that's why the topic is finding unknowns in matrices. So I don't know if this is the exact topic, the exact way it is like referred to in textbooks, but then you are going to get what I'm trying to say. So example one. So we've got this. Um, Matrix A is equal to you have one, you have two, you have two and one, and then matrix B is equal to B1 and B2. So what we have to do here is that we have to determine the value of K to satisfy AB equals KB. So determine the value of K where AB equals KB. Alright, so how do we do this? So basically, this is just talking about multiplication of matrices, right? So we are basically supposed to express this in terms of we have one, so one, so it is AB, right? And B is B1, B2, then equals to we don't know K, so K is a scalar that should multiply B1 and B2. So how do we get our K out? So what I just have to do is to multiply what is there. So and of course it must have, for you to be seeing this lesson, must have passed through multiplication of matrices. So we continue. We just have one multiplied by two. That's your row multiplies your column. One multiplied by two. That is one, which is still B1. One times B1 is B1. Then two multiplied by B2. So B1 plus B1 plus two B2 um in your matrix. Then two multiplied by B1. So you have two B1 plus one multiplied by B2 is B2. So this equals K. Uh, um, so let me just multiply this one out. So I have K B1 and K B2. All right. So B1, normally, if you remember from your matrix inversion, so we can just, like using the inverse method, so we can just say this is equal to this anyway. So B1 plus 2B2 equals to K B1, right? Then 2B1 plus B2 equals KB2. So I can call this equation 1, I can call this equation 2. So what I then need to find from here is I just make K the solid of formula in any of these equations. So let me say I'm picking equation 1. So you make K the subject, make K the subject of equation 1. So from there I'm going to be having B1 plus 2B2 equals K B1. So I divide by B1, I divide by B1. So K is standing alone. K equals B1 plus 2B2 divided by B1. This is equation 3. So because I got this from my equation 1, so all I just have to do is to substitute this into equation 2. I could have, I could choose anyone I want anyways. But then let's substitute it into equation 2. So substitute um, equation 3 in equation 2. So I'm going to be having 2b1 plus b2 equals, then k is all of this, b1 plus 2b2 over b1, and multiplied by the b2 that is already here. So what can I do? So I just kind of cross multiply by b1 to eliminate this person. So when I cross multiply, I'm going to be having b1 into brackets 2b1 plus b2, and this one will be equals to b2 into brackets b1 plus 2b2. So from there, b1 times this is 2b1 square plus b1 b2 equals b2 b1 plus 2b2 square. All right. So when you just try to like write items. This will cancel this, right? Or let me just, for those that may not understand it that way. So I have 2b1 squared plus b1 b2. When this person comes, it becomes minus b2 b1 is same as b1 b2 anyway. So right, minus okay, let me put it this way: b2 b1 and equals to 2b2 squared. So this cancels this, like they're the same. So essentially, we are going to be having essentially we are going to be having 2b1 squared equals 2b2 squared. All right, so 2 cancels 2. B1 squared equals b2 squared. So that simply means b1 equals b2. All right, because the square take each other out, so b1 is equal to b2. All right, so I remember initially I was saying that we should substitute what we got into equation 2, like that is the right thing. So it's not like substitute into equation 1 or 2, like just equation 2. Since we got the value of k from equation 1, so we substitute that value into equation 2. So it is b1, b2. It is this one that we can now choose to substitute inside any of the equations now. So I could decide to say, okay, substitute, make b2 b1 right in this equation or this equation. So I'm still going to get the same answer. So I'm going to do for both, but in an examination you don't have to do for both. I just want to prove something. All right, so substitute the value of let me call this equation 4. All right, so substitute equation 4 equation 4 in, let's say, equation 1, for example. So when I bring that here, so that means whenever I have b1, I replace it with b2. So this is my b1 in this place. I'm going to replace it with b2. So I'm going to be having b2 plus 2b2 equals k into bracket b2. All right. So I make everything b2. So here you have 3b2 equals k b2. Divide both sides by b2, and k equals 3. All right, so again, let's assume that I'm choosing equation 2. So substitute equation 4 in equation 2. So here too, whenever I say b1, I put b2 instead. So 2b1 here become, this 2b1 here become 2b2 plus b2 equals k b2. Alright, so this one is still 3b2 divided by b2 is still equal to k, and then k equals 3. So the k that we are looking for is actually equal to 3. So that's it. That's it. So that's that value expression. It says determine the value of k that satisfies this condition where ab equals to kb. And if you want to prove it, you might choose to prove it. Alright, so if you want to prove it, what we'll just do is, this is AB, right? So if you want to prove that AB is equal to KB1 B2, you are not required to, like, you know, let's just try and see. So we are going to be having one, two, um one, two, then two, one, then B1 B2. Now our stuff made us to realize that B1 is same as B2. So I could just say B1, just say B1 B1. So I want to check if this is going to be equal to 3, 3, then okay, to still be my B2 here, 3B1, then B2, for example. Alright, so if you just do this, 1 times B1, what that was the equation that we had here. So we are going to be having B1 plus 2B2. Then you are going to be having 2b1. We've already done it before, so I'm just copying it. 2b1 plus b2. Alright, so when you do b1 plus, we are going to get, since b1 equals b2, this is going to give us 3 b1, and this one is also going to give us 3 b2. What do I mean? Like, I just kind of make this one, like, since my b1 is same as my b2, so instead of putting b2 here, okay, let's say we have something like this. Right now, do since b1 equals b2. So I could just put b1 here, like all through. So I'll be having b1 plus 2b1, which will give me 3b1. Then instead of putting b1 here, I could just put b2 instead, because they are the same thing. I'll be having 2b2 plus b2 equals 3b2. b2. So this is correct because at the end of the day, 3 times b1 is 3b1, 3 times b2 is 3b2. So I hope you understand what has happened there. So now we are done with this particular question. So if you see questions like this, I believe that you already know how to solve them. So let us go to the four other examples. So all right, guys, we have two other examples on the board. So this ones have to do with determinants, and of course, you can't be here if you've not gone through things related to determinant before. All right, so this is they are basically square matrices, 2 by 2 matrix, 3 by 3 matrix. You know what that means. So how do we get the value of x here? For example, so um, solution. So remember that for determinants, yeah, determinant is 0, yeah, determinant is 2. Um, so just do this multiplied by this, then minus this multiplied by this. Simple. This is a 2 by 2 matrix. So we have x plus 2, right? Into brackets x minus 3, then minus 2 into bracket 7 equals 0. So x times x squared, then minus 3x plus 2x minus 6 minus 14 equals 0. That's not a problem. So x squared minus x minus 6 minus 14 is minus 20 equals 0. So how do we get the value of x? So we can use completing the squares method. What two numbers can we multiply that will give us minus 20x? Of course, before now I must have done quadratic equations, and then that will give us minus x. So our best bet is x squared, then minus 5x plus 4x. All right, let me do a plus here. So minus 5x plus 4x will give us minus x, and minus 20. Then this equals to 0. All right, so we have x squared plus times minus is minus 5x, then plus 4x, then minus 20 equals 0. This, and this. So collect like terms, x into bracket x minus 5, then plus 4 into bracket x minus 5 equals 0. So we are going to be having x minus 4, x minus 5 equals 0. So the value of x is equal to 4. Um, is it x minus 4, x minus 5? X is x, yeah. So x plus 4, x equals minus 4 or 5. And that's it. And if we try to prove it, again, proving is not part of what you're supposed to do. If you want to prove it, when x is minus 4, when x equals minus 4, so what do we do? Minus 4 plus 2, then 2, 7, x, no, 4, 4, minus 4 rather, minus 4, minus 3. So minus 4 plus 2 is going to give us minus 2, 2, 7, and minus 7. Minus 2 times minus 7 is 14, minus 14 equals 0. So, which is equal to 0, correct? Then when x is 5, when x is 5, I'm just going to have 5 plus 2, 5 plus 2, 7, 2, then 5 minus 2. So this is going to give us 7, 2, 7, is this correct? 5 minus 3, okay, 7, 2. 7 times 2 is 14, minus 2 times 7 is 14, which still give us 0. So that's how to solve this. So the value of x, since we add a quadratic function, the value of x is equal to minus 4 or 5. So in the same way, we are going to do this. But remember that this one is a 3 by 3 matrix. And in solving it, 3, 2 minus 1, 4, 1, 1, 1, x, and 3 equals 2. So if you recall, that's to find the determinant of 3 by 3 matrix, you first put signs here, plus, minus, and plus. So as when I do this, right, something like this. So 3 plus 3 into bracket, what is left? 1 times 3, which is 3 minus x times 1 x. Then is this minus 2? Okay, this is 2. This is just okay. I did something like this. So This is 2. Then minus 2 into brackets. This is 3, 4, 1, right? 3, 4, 1. So if I strike this guy out, this guy out, I have 4 times 3, which is 12, minus 1 times 1, which is 1. Then this is a minus 1. So plus minus 1 is still minus 1, minus 1 into brackets. 3, 2 minus 1. 3, 2 minus 1. This is 1. This is x. So minus 1, I do the same thing, just cross this guy out, cross this guy out. So I have 4 times x, right? Which is 4x, 4x, then minus 1 times 1, which is 1. So everything equals to 2. Alright, so 3 times 3 is 9, minus 3x. Alright, 12 minus 1, that's 11. So minus 2 times 11, minus 2 times 11, that's minus 22, minus 22. Minus 1 times 4x is minus 4x. Then minus 1 times minus 1 is plus 1. Everything equals to 2. So from here, I just leave x on this side. So 9 minus 22, that's minus 13. Then minus 13 plus 1. Let me correct like terms. 9 minus 22 plus 1. Okay, maybe I should put minus 2 here too. Minus 2. This 2 comes here because minus 2. 3x goes to the other side, it's 3x. Then 4x also jumps the equal to sign plus 4x. I think that's all. So 9 minus 22 is minus 12, right? So minus 12 plus 1 minus 11. Minus 11 minus, oh, is that correct? 9 minus 22 is minus 13. Yeah, minus 13. So minus 13 plus 1 is minus 12. Minus 12 minus 2 is minus 14. Minus 14 equals 7x. Divide both sides by 7, 7, and x equals minus 2. So it's not difficult. So x is just minus 2 there. Alright, so you can see that these things are pretty easy. So just know how to get your determinant normally, and please don't do mistakes. So like be careful with your calculations. And like I said, plus minus plus, like that's always the case for a 3 by 3 matrix. So don't forget it. And if your minus here, for example, is that, let's say this was a minus 2, so that would have been minus minus 2, which would have turned it into plus. Just be careful with these figures, and it's not a problem. So let's talk about the remaining two exercises before we then give ourselves an assignment to deal with. Yeah, so look at these two other ones that we have on the screen. The first one says you should find a determinant in terms of x, which means you're not going to get a definite number. So it's going to be an expression. Then the next one is like this: find a and b. So just different formats, of asking different questions. So solution, um, and this number four is looking as if it's a crazy thing, but it is not, right? And thankfully, it's because of the zero that is here. So what do we do? Plus, minus, and plus. So when we do that stuff that we did the other time again, you rule out this part, you rule out this part, so we are left with this small space. So we are going to be having x, which is plus x, into brackets, then 2 times 4. Okay, 2 times 4 is 8, minus 1 plus x times 3. So we are going to be having 3 into brackets, 1 plus x. Alright, that's about that one. Then when we are done, we come to minus 1. So minus 1, we open the brackets. Okay, so I clean this particular one. So we are going to be reading out what is here now. So we are left with this part, this, and this. So minus 1 into brackets, 4 times 4 into brackets, 1 minus x. This times this. Then minus 1 times 3 is 3. Okay, those the entire thing. Then plus 0. Okay, just 0, because 0 is the number that will be here, then into brackets, whatever, whatever. Okay, but since it is just 0, so 0 multiplied by all of those things will give us 0. Right, so no need to like start solving anything, that's already helped us out. So this is going to be x into bracket 8 minus, so you have to be careful a little bit here. Minus 3 times 1 is minus 3, and minus 3 times plus x. Minus times plus is minus. 3 times x is 3x. So we're done. minus 1 open bracket, 4 times 1 is 4, then 4 times minus x is minus 4x, all right, then minus 3, and all of this equals to 0. All right, so from here, x, 8 minus 3 is 5, minus 3x, you have minus 1 into bracket, 4 minus 4x minus 3 equals 0. So I think this is a little bit simpler now. X times 5 is 5x minus 3x squared. Then I can multiply through 2, but I just want to do this first. Um, 4 minus 3 is 1. So you have 1 minus 4x. No, it's not equal to 0, please. It's not equal to 0. It's just plus 0, so I can take that off. It's not equal to 0. Alright, so minus 1, and 4 minus 3 is 1 minus 4x. Okay, so 5x minus 3x squared. And minus 1 times 1 is minus 1. Minus times minus now. Okay, it's minus and this minus is plus, and 4x. Alright, so we have minus 3x squared plus, I'm just like rearranging, plus there's a plus here, plus 5x. Um, plus 5x, then is this meant to be plus 4x? Well, plus 4x, then minus 1. So you have minus 3x squared plus 9x minus 1. So I just hope that I'm not a little bit mistaken. So where exactly is that question? Um, yeah, I had plus 5x minus 4x. In the question, this is 1. Okay, I had written a plus 1 instead of a minus 1. Minus, because you can see, so I made that kind of mistake in my solution here. So what is on the board is correct. So again, you can see how easy it is to make these mistakes. So minus is supposed to be here. So this guy also have been minus 1, which it is, right? Then 4 minus 4x. I mean, that's, yeah, very cool. So here's the answer that I was supposed to add. So the next one now says number 5. So how do we deal with number 5? Um, Number 5, we have so we know this is going to multiply this, right? So 3 times a, we have 3a, then plus 2 times, so plus 2 times 4 is 8. So when we are done, then that multiplies this. All right, on the other side, so 3 times 5 is 15, and then plus 2 times b is 2b. So now that we're cool with all of this, then we come to the second part here. This will multiply what is here first. So that's a. So minus 1 times a is minus 1a, or just minus a. Then plus 16. 4 times 4 is 16. And as we're through with that, come here. So minus 1 times 5, that's minus 5. Um, 4 times b, so this is plus 4b. And all of this is now set to equal to 2, 21, 18, 18, and then 7. So basically, 3a plus 8 is equal to 2. That's what it is telling us. So 3a plus 8 equals 2. So apparently, 3a equals 2 minus 8. 3a equals minus 6. Divided by 3, divided by 3, a equals minus 2. Alright, so we also have a here. So let's verify if a is indeed minus 2. So we can also say, we don't need it because we already gotten a, but like let's just be sure that a is minus 2. So we have minus a plus 16 would then be equal to, since it's in this position, it's going to be equal to this, equal to 18. Alright, so minus a equals 18 minus 16. Minus a equals 2. Definitely a equals minus 2. So that's correct. Is minus 2. Then for b, 15. 15 plus 2b equals 21. So 2b equals 21 minus 15. 2b equals 6 and b equals 3. So to verify, let's use this last one. Minus 5 plus 4b will equal to 7. So 4b equals 7 plus 5. 4b equals 12 and b equals 3. So at the end of the day, we can see that a and b equals minus 2 and 3. And with that, we are done. So again, like I said, if you've done this particular one, you don't have to do this one again because A has to give the same value. The same thing for this one. But I just have to do both because I'm teaching you anyway, so it's a class, and then I just really want you guys to like see that we can verify our answers. Our answers are verifiable. But again, if you've gotten your A with one of those things on your B, like you are, done. All right, so that's that. So you can say all of these things are pretty simple or simpler now that you've understood them better. So let's look at your differentiates of assignment. So here, everyone, here we go with assignment, like looking for different things. A minus 2 1 1 2 1 k 1 3 minus 1 equals 23. Find the unknown, which is k, of course. And here, triple x somewhere 1 1 0 1 0 1 equals 0. Find x, that's the unknown. Then C 5 6 3 7 x 7 minus 4 y equals minus 2 26 minus 16 21. Find x and y obviously. Then here 5 6 minus 2a minus 203. Then 240b. This is b minus 5 and 6 equals 30 26 19 and minus 19 and 10. Find a and b. Then x cubed 6 2x 3 equals 0. Find x. All right. So yeah, that's that. See you when I see you again. Bye.